So here it is. This is class today. I don't know how well you'll be able to see these, but we're going to go over problems 3, 4, and 6. So there's the problems 3, 4, and 6. I'll move it around. There you go. So right now, try doing 3, 4, and 6. Just write it on a piece of paper, and in a minute I'll put the answers up. Peace, everybody.
A red and a white allele for both parents. So bizarrely enough, if you had two pink parents, you end up getting back red, pink, and white in a 1:2 ratio. Right, so you'll have the genotype ratio is 1:1, the phenotype ratio, because pink has to be homozygous, red has to be homozygous red, and white has to be homozygous white.
That's not fire alarm. That's just pausing.
Right. Here's number 4.
Number 4.
Number 4 down there. Again, very similar. This is incompletely dominant. You have curly hair, straight hair, and then wavy hair. And in the it says the mom has the curly hair, so she has the eggs up here. So it's 2 curly alleles, and then the dad has wavy hair, so he's got possibilities. It's a 1:1 ratio of homozygous curly versus heterozygous, and a 1:1 ratio of curly versus wavy. Oh. Or if you want to say 50,
number 6.
You've got the black chicken, the white chicken, and the erminate chicken, which is black and white speckled. And in this case, you have what would happen if a black chicken, this is the mother, was crossed with an erminate black and white speckled rooster, the father. And then you get the same thing, 1:1 ratio of black to erminate, no white ones. And then the phenotype ratio, I guess that was the phenotype ratio. The genotype ratio is 1:1 homozygous black to heterozygous.
Okay, now we're going to do some
How did that go?
Notes on dihybrid crosses. So right now, Mr. Wolf's getting everything out. So
okay, well,
I'll pause this and we'll get back to it in a minute.
We can do this really quickly, and especially if you weren't quite sure how to do dihybrid, you should definitely be paying attention. So if you want to jot, I always try to my students during the day talk about, you shouldn't just look at and write every word you see on the slide. Try to listen to what the teacher's saying and try to write down, what's important here. So really all dihybrid crosses, you're looking at 2 traits at once instead of just 1 trait. So you're looking at what's the chances of a child having, black hair and, free earlobes? What are the chances of both of those things happening at the same time versus just what's the chance of a kid having free earlobes? That's all this is. It's just doing 2 traits at once, dihybrid instead of monohybrid. There you go. And that's what I was just saying here. This dihybrid cross determines the probability of 2 traits instead of 1. This, just to connect this back to one of the terms you were doing. So this guy named Mendel, the Austrian monk. He had all these genetic experiments he did, and he came up with these 3 laws: law of dominance, law of segregation, the law of independent assortment. And that's what the law of dihybrid crosses are based on, the law of independent assortment, that 2 traits do not have to be always inherited together. In other words, if you're talking about black hair, red hair, free earlobes, and attached earlobes, it doesn't always have to be black hair and attached earlobes. It can be black hair and free earlobes, or red hair and attached earlobes, or red hair and free earlobes. The traits are independent of each other. That's what the law of independent assortment means. The traits are not linked with each other. They can be independently inherited.
One has no influence on any other. Lots of times people with blonde hair, what color eyes do you have? Blonde hair, blue eyes. Does that mean that everybody that's got blue eyes has blonde hair? No. They're not linked, but it's also, your parent. Those traits are coming from your parents. So that's what this independent assortment is. One has no influence on anything else.
All right.
No.
Okay, why don't you jot these things down, fur color and coat texture, so, write that down and then we'll go through how to do one of these.
So looking at fur color, which is the dominant trait? Black. How do we know that? Well, first of all,
Capital.
it's the capital B, black.
I didn't want to hit you with confused.
You don't need to write, this is what I mean by not writing everything, you don't need to write all this stuff, because that's what we're gonna do. We're gonna cross two heterozygous individuals that are heterozygous for both of those traits.
So what does heterozygous mean? Different. Oh, look at that. There
There's
it is.
now you might wanna write this down though, this would be the two parents right here, what you just said, they're different for each trait. They have the dominant and recessive allele, so, what do these parents look like?
They're black with rough.
They're black with, the black rough fur, right, both of them. They look the same. I don't know if you're talking about guinea pigs or something, I don't know.
Bears.
Bears, yeah. But these look the same, right? They both have the same phenotype. They're black, rough fur. Rough coat texture. Okay. So I will show you, maybe Mr. Urbanek has different ways of doing this. We'll see. Test this.
I know, I have that same problem. Touch it and it goes crazy.
Mm-hmm.
Miss Naples has that problem too.
Miss Naples has a lot of problems.
Oh!
I'm just joking. I love Mrs. Naples. She's my favorite people.
I'm sorry, I can't use that L word. Unless we're talking about pizza or my dog.
Love.
I can't use that word.
You have Mrs. Naples, so ask her why. Tell her, hey, I heard your nickname's Bulldog, and see what she says.
Wait,
All right, so here's how you can do this.
Chicken man.
Yeah, that's me.
wait, what?
You guys do FOIL in math, right?
Yeah. First, outside, inside, last.
Okay, it's the same concept. Watch this, right? So, but you do want to understand, so if you go take this back to meiosis, remember, during meiosis, when this guinea pig makes sperm or egg cells, what's going to happen to its two alleles for color? They're going to stay together or come apart? In other words, are you going to pass on both of your alleles or just one?
Just one.
Just one. That's called the law of segregation. They separate, right? Now, when those separate, which one of these alleles are, like if this big dominant allele, which one of these is it going to end up with? Be careful with your answer, right?
The not
Okay.
The recessive.
Okay, there you go, right? It can be with either one, right? This is the law of what?
Dominance.
Independent assortment. It can be, what Mr. Irvin's just saying, they're not really linked. So here's what the FOIL means, right? That one can be with that one because
Why is it moving?
Elliot just said that. So you can have the first together. That's a possible gamete. Okay, then this one could also be with what?
The little R.
The recessive one. So there's your outside. Now, the recessive allele for color can be with the dominant allele for, there's your insides.
RB.
And then the last, right? Both recessive alleles. So there's the four possible sperm or egg cells that parent could pass on. It could be any of those four.
And if you have two B's together or two R's together, that's telling you automatically you made a mistake. Because you won't have two B's together and two R's together because you're getting one of each of them. So you never have two together.
For the little b, big R, can you do big R, little b?
By tradition, we always put the capital first.
Yeah.
And then we keep them all the same. So you would never go capital R, small b.
Okay.
Yeah. And that has to do with other issues, but By tradition, we just keep them that way.
Okay, do you really need to go through and do the same thing for this pair? Not really, it's gonna be the same exact thing, right?
In
They're
this
both
case,
In this case, right, if they were different, you'd have to do it for both parents. Now, go ahead and make that. So with the dihybrid cross, you gotta make this giant Punnett square, 16 boxes, and you're gonna put your 4 possible sperm or egg cells across and down, one parent, the other parent. And then we'll show you the common mistake that kids make when they go to fill these in. At least
I'm guessing your mistake is the same as my mistake.
So don't fill it in yet, just set it up. Don't fill it in yet, because again, we'll show you the common mistake that kids make, students make,
Just checking for the color.
and then you won't make that mistake.
I probably will.
Oh, I hope so. Now
I'm
you
gonna
don't
fill
have
just
to
a
show you how
couple.
to do
I'm
it.
just gonna fill a couple of them in.
Yeah, good.
Oh.
Okay, so the mistake that a lot of times students will make is they'll fill this in. They'll put like a B and an R together. They would write this down, like that box, they would put this and this, which again is not correct. You want to match your letters together. The alleles for color and the alleles for texture should always be together. So you don't have like a B with an R, you have the same alleles together.
So what he's saying is these two, don't do it that way. Don't put a B and an R and a B and an R, BR, BR together.
That one B is supposed to be lowercase.
Oh yeah, I guess I didn't even look at the letters. I just wrote it up there.
Okay.
Duh. You're right. I screwed that up.
But again, if you know what you're doing here, fill them all in. Go ahead and knock them out, fill them all in. Can we both write at the same time? Try. Right on that while I write. See what
You should do something like 4 at one time.
The max is 10.
The max is 10.
Oh, really?
Actually?
Really? That's pretty
I
sweet.
don't know why, but we talked about this in like 5th grade and then summer.
Oh, wait.
I did not talk about this in 5th grade.
Not a people.
We talked about Charlie's Angels when I was in 5th grade. Good old Farrah Fawcett.
Yeah, I have no clue.
She's been dead probably as long as they've been alive.
This is true.
So do you do it both ways?
Oh,
I try to do it more like this.
oh.
That's the way I try to do it, that way. Do you guys try to fit them more that way?
No, I usually do them like you do.
I just find that if I do it that way, I'm just jamming.
Yeah,
It
yeah,
seems like I'm
yeah.
jamming too much in there.
Yeah.
My hand hurts.
No, come on, dope.
Dope.
I was a dope. I find these very satisfying to do.
I find it.
Wow. That's cool.
I'm not gonna go through and do like all the genotype ratios, phenotype.
Okay, that's fine.
That'd take forever.
That would be.
One of the reasons why you don't want to do it like this, BR, is this is just doing one generation, but if you're calculating a second generation, now if you do that first, outside, inside, last, it doesn't foil properly. So that's why you have to do it this way with the 2 B's together and the 2 R's together.
That's interesting. When you erase, I can't write.
Oh, is that right? Yeah, you're right. That's sort of fun.
Fun sabotage.
All right, so let's total them up then, and I mean, this is typically the way I do these. I mean, there's other ways, but I write down the 4 possibilities: black with rough texture, black with smooth texture, white with rough, white with smooth. And then I just count how many there are of those things. So like, let's find all the ones that are black with rough texture. Is this one?
Yes.
Yeah. Is this one?
Yeah.
Yeah. This one?
Yes.
Yeah.
Yes.
Yeah.
Yes.
Yeah.
No.
No.
Yes.
Yes.
No.
Yes.
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 No. No. Yes. No. No. No.
All right. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I put down 9. So there's 9 possibilities that will give you black with rough texture. All right. Let's pick a different color here. All right. Let's go black with smooth texture. Is that one black with smooth texture?
Yes.
Yep. Is that one?
Yes.
Mm-hmm. Is that one?
No.
No. No.
No. No. No.
Where's our mistake?
What am I missing one out there?
If you go on the far right row, the second one down, that's supposed to be capital.
Oh
B.
yeah, that's supposed to be capital B.
There.
That was mine.
3 of them, right? 3 that are black and smooth. Let's do white and rough, right? White with rough. You got, is this one?
Yes.
Yep.
Yes.
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 Yes. So there's 3.
3.
And then how many white and smooth?
1.
1. Okay.
Right
So
And
call
don't
this
get
a,
don't get white and rough confused with white and nerdy. Big difference there. I'm white and nerdy. I'm white and nerdy.
guys ever heard that?
Weird Al, baby.
While you're working here.
Can you do a break real quick?
Yeah, let's do that.
All right, we're gonna take a break.